Chem 1 Statics Example 9. In this example, we were asked to look at a force acting on a particular object in two different ways, acting horizontally and also acting at an angle to the horizontal. We have a rough horizontal plane, so I've already started to draw the forces on the diagram here. The mass is 8, so the weight is 8g, and we know that it's a rough plane, so we've got a frictional force being applied. What we're asked to do is find the maximum possible force P, which could act on the mass without causing it to move. In other words, it's in limiting equilibrium. So for the first one, with P acting horizontally, considering first of all the vertical is R equals 8g, that tells us that the frictional force in limiting equilibrium would be F equals mu R, so it's 0.5 multiplied by 8g, and so the frictional force would be 4g. If we now look horizontally, we know that if we do F equals ma, because it isn't moving, we know that P would be equal to the frictional force. In other words, P is equal to 4g. Working out 4g on your calculator gives 39.2. And so if we're giving it to two significant figures, which we should, it would work out to be 39 newtons. So that's very similar to the previous example, example 8. Now for this one, it's a little bit more complicated because this angle P is acting to the horizontal, and if we read the question, it says it's acting at 60 degrees above the horizontal. So this angle here is 60. We approach the question in exactly the same way, but we've got to remember that P now has a vertical as well as a horizontal component. So if I resolve vertically to start off with, R and P sine 60 act upwards, and 8g acts downwards. Now, because we want to know friction, if I rearrange this to get an expression for R, so it's 8g minus P sine 60. That gives us an expression for R. And then we know that in this particular question, mu is a half. And so the maximum value of friction, the limiting value, is 0.5 multiplied by this expression here for the normal reaction. So that's our frictional force. We can't quite work it out yet because we don't know the value of P. In fact, that's what we're trying to find in the question. So we'll have to leave it as it stands there. Now, if we do F equals ma horizontally, again, because the acceleration is 0, we know that forces to the right will balance out with forces to the left. So in other words, when we look horizontally, P cos of 60 will be equal to friction. Now we've got an expression for the friction here, so if we substitute that in, and then it's just a case of making sure we rearrange the algebra carefully. Try to avoid putting these numbers into your calculator and getting long decimals, because that's how we get rounding errors. So if I just multiply this out, we're going to have P cos 60, 0.5 times 8g is 4g, and then we'll have 0.5 multiplied by P sine 60. Now because we want to find P, we've got two terms that have P. We need to get those on one side together. So if I bring that one involving sine, if I bring this one over to the left hand side, that'll become plus 0.5 P sine 60 equals 4g. Now you may remember the trick from school. When the subject, the thing that you want to find, occurs twice, we need to make it occur once, and the way we do that is by taking P out as a factor. So we'll have P, and then in brackets cos 60 plus 0.5 sine 60 equals 4g. And so the last step, if we divide by this large number in the brackets, cos 60 plus 0.5 sine 60. And at this stage, if you now type all of that into your calculator, that will avoid getting lots of rounding errors as you go through. Rounding your answer to two significant figures, you should find that you get an answer of 42 newtons.